Hello students, today we are going to learn about the language processing. In the earlier lectures, we have talked about various categories of computers and the programming languages, and today we are going to study about language processing. As we have studied so far that we need programming languages to give instructions to the computers, and how these instructions are understood by the computers, what processes takes place in the background. We are going to study together this thing today. So let's get started. First, this is the category that we are going to study about today: translators. Now, what are translators? Translators are actually programs that converts the assembly programs or the high level language programs into the machine code. As we have studied before, that computers do not understand high level programs, and these high level programs needs to be converted into machine codes, binary codes, a series of zeros and one, and every program needs to be converted into this machine code, and computers only understand this machine code, and that's why we need translators, because we cannot write machine codes because it is very difficult to write, and modern high level programming languages consist of English words and programs which are not understood by the computers, and that's what the translators do. They actually serves as a medium between us and the computers. We write programs in the high level languages, translators convert these programs into machine codes, and these machine codes are finally understood by the computer, and the computers follow the instructions written in the program, and they finally give us the output. And there are three type of translators that we are going to study about: assembler, compiler, and interpreter. Now all of these have different functions and different way of work. We are going to study about each of them one by one. Let's get started with the assembler. So assembler, they are actually the simplest kind of translators. They convert assembly language into the machine code. Now the program written in the assembly language is called a source program. Now we know that the assembly language consists of English words and numbers, and these English words and numbers are not understood directly by the computer. So this assembly codes needs to be converted into the machine code, which is finally understood by the computer. And the process of converting assembly code into the machine code is done by the assembler. Assembler is a program which converts the source code written in assembly language into the machine code, which can be easily read and understood by the computer. And the computer reads this machine codes, understands what we are trying to explain to the computer, what instructions we are trying to provide to the computers, and the computers follow that instructions and give us the result. Next are the interpreter. These are actually advanced version of the assemblers. An interpreter, usually when we write a program, high level language program, that program consists of many lines of codes. What an interpreter does is interpreter translate this high level language into the machine code line by line. So what does a translator do? It just reads the first line of the source code, the code written in the English phrase like language, high level programming language. It reads that line, converts that line into the machine code, and execute it. So what happens is interpreter reads the first line of the program, translate that first line into the machine code, and then executes it. When I say executes it, it means that whatever instruction we deliver to the computer in the line of code, that instruction is understood by the computer, and the computer follows that instructions and carry out the tasks that is written in the first line or the second line of code. So interpreter reads the first line, translate into machine code, executes it, then move on to the next line, reads that line, translate into machine code, execute it, and then move on to the third line, translate third line into machine code, executes it, and then keeps going on and on and on until all the lines of the code are executed. If you I have already given you examples of how high level programming code looks like in the lecture 2. If you do not understand some of the words I'm using here today, you can go back to the lecture 2 and listen to it once more. So this is a simple working. Plus your program might have some errors. Now errors, whenever we write a high level program in some high level programming language, we have to follow a certain rule, a syntax, and every programming language have a syntax. Now syntax is a set of rule, a method of writing lines that makes it easy to write code in that language. And whenever we make an error in writing the syntax of a programming language, the interpreter does not understand it. So like as we speak English, we have to follow certain rules that how should our structure of the sentence should be, what words we can use, what words means what, and the same happens in a programming language. So while writing a program in a high level language, you have to follow certain syntax rules, and when you do not follow certain syntax rules, and if you commit an error, the interpreter stops working at that line, and it tells you that there is an error in that line, and then you have to go back to the source code. You have to correct that error, and you can start the interpreter again. So interpreter keeps reading the line, turning it into the machine code and executing it, and if there is an error in any line, interpreter tells you that the line contains an error, and then you have to go back and correct it. So that's defined set. And plus interpreter runs a little bit slowly because every line is translated one by one. So if your program contains, let's say, 200 lines, so each line is read and executed one by one. So that's because of that the execution time is slow in interpreter. Next we are going to learn about the compiler. So a compiler translates the entire program into the machine code in one go. That means the whole high level program is translated into the machine code instantaneously, like in one go. Whole program is translated into machine code instantaneously. As an interpreter, we have studied that that interpreter turns each line into the machine code one by one. It first translates the first line into the machine code, then translates the second line into the machine code, then translates the third line into the machine code, and then executes line one by one. But it does not happen in compiler, and compiler translates the entire program into the machine language in one go. And if you have any errors in the syntax while writing a program, the compiler tells you about the first error that it finds after the compilation is done. So translators, what does the translator do? It just take the source code is taken by the compiler converts all the source code into the machine code in one go, and if there are not any errors, then that machine code is executed by the computer, and then you get your desired output, the desired result, the desired instructions, steps that you given to the computer, and the computer follow those instructions. Now the instructions could be anything. It could be like adding 2 and 2 or writing certain something, and various programs are actually a set of instructions, and all these instructions are followed by the computer, and then after you get your desired output. So that is the main difference between an interpreter and a compiler. An interpreter translates each line into the machine code one by one, whereas a compiler translates the whole program into the machine code in one go. A translator tells you, an interpreter tells you about the errors it finds in a line, and if and only if you correct that error, then the code is carries on. Whereas in a compiler, all the errors that the compiler finds in the code will be told to you at the end of the translation process, and you can get rid of that error in the source code, and then you can start the compiler again. And if there are not any errors, that whole program will be converted into the machine code, and then finally you will get your desired output. So that's it, students. This is all we are going to study about today. This is the end of the chapter 1. So we have completed the chapter 1 successfully. Thank you so much for listening. Bye.